here with Richard Schmidt, who is our kind of resident guru when it comes to space and our knowledgeable person when it comes to Saturn. And we're going to talk about what happened about 15 years ago in July. So Richard, I'm going to let you take it away.
Okay, very good. When you were so excited about what was happening, I thought you were talking about the Nationals.
Well, we'll get to them later.
Oh, yeah. Okay. Well, we're talking today about a spacecraft called Cassini-Huygens. And where did those names come from? Well, it all started with Galileo. He put his telescope up in the sky there. Oh, it was about 1610. And he looks up and he sees, hey, look, there's other things up there. And he saw Jupiter, and he saw a moon going around Jupiter. And so he got really interested in things that we hadn't seen before. We can see them now with a telescope. And he looks a little further and he sees Saturn. It's got rings around it. My goodness. Okay, so that was something new. But he couldn't see too much because his telescope was kind of new and not very clear. Well, Huygens had a better telescope. This was about 1655. And so he takes a look up there and he says, hey, you know, those rings is really a disk around around Saturn. And so he's saying, you know, that's what's really going out there. It's something new, brand new. And Huygens, he goes up there and he sees Titan, a very large moon. It's the largest one of Saturn's. And so Huygens had that discovery as well as seeing that there was a disk out there. Cassini, he came along later, and with a better telescope again, he was able to see that the disk had some spaces in it, some divisions. So the Cassini-Huygens spacecraft was named after these early discoveries of these new features that were discovered about the planet.
And these were unmanned spacecrafts that NASA sent into
Yeah, NASA
orbit.
had sent out some early ones, Pioneer 11, Voyager 1, Voyager 2. They passed by the planet and took some close-ups of it. All unmanned. We don't send men that far, okay? And then, so we come up to now, we're going to send out a spacecraft that's specifically going to go around the planet itself and stay there for a while, okay? And now get detailed data about the moons and about the planet itself. And so the first image that we can bring up on the screen is the spacecraft as it came into Cape Canaveral. The Huygens probe is on the left-hand side. If you look on the left-hand side, there's like a golden thing there. That's the Huygens spacecraft that's attached to the Cassini. The Cassini is the rest of it. And they got a next image, if you'll bring that up, shows you in detail all the stuff that's on it. That thing is cram-packed with stuff, okay? They got that. On the top, you can see a big dish. And that's how they can communicate back. That's a high-gain dish. Excuse me. It's actually got a little antenna on the top, right in the center, that is omnidirectional. I'm not quite sure what they did with that, but probably for quick locations type of thing. They got a big bar coming out from the side looking at, it's a magnometer, so they can check on magnetic.
And does this spacecraft like orbit around Saturn? Or
Yes, it goes into orbit around Saturn.
It would just seem to me that it was really fortunate that it didn't get damaged by anything, you know, by all the debris. And
all the debris. Where's the debris?
Well, isn't it? I guess it's made closer to Earth, right?
Space is so empty. It's
okay, well,
really
I just
empty.
keep hearing that we have a lot of garbage up in our atmosphere. So once you get past that, you're in good shape then.
Even with the garbage that's around Earth that we've put up there, all that stuff, there's so much space, you know.
Okay.
It's hard to run into some of that garbage.
All right.
But boy, if you run into it, the speeds are so phenomenal, it just penetrate and explode whatever you got.
Okay.
So you do have to watch out for debris. Yeah. Okay, let's go on and see what else we got here. This was a big program. It was supposed to be about 38 years. Actually, it was less than that. They extended it to 38 years because they had so much success. They were getting some good data. They extended it a couple of times. And so overall, it would have been a 38-year operation. And that was handled by Jet Propulsion Laboratory out in California. And so they were managing this very large program. NASA was in it, and they did the Cassini-Saturn orbiter. The Italian Space Agency, they provided the high-gain antenna and several science instruments. The European Space Agency was in it, and they did the Huygens lander. And that's quite a deal, too. You're going to try and land on Titan, the largest moon. And so the three agencies have to work together. Jet Propulsion Laboratory oversees it, makes sure everything goes together. And the Cassini orbiter carried 12 science instruments. They were broken down into 3 disciplines: the 4 optical units. They had 6 instruments that were looking for dust and plasma and magnetic fields. And then they had 2 microwave instruments up there too. The Huygens lander, it had 6 instruments to study Titan. It measured physical, chemical, and electrical properties of the atmosphere, and also looked for particles that were around. And it employed an imager, so they could take pictures. And if you'll bring up the next image, we see the launch of this Cassini-Huygens unit. They didn't have enough power to really get all the way to Saturn with the rockets that were available. So what they schemed up, they says, hey, look, let's use gravity to help us get the extra speed, and we'll get out there using that. And if you bring up the next image, you'll see what nonsense goes on here. Look at this. They had to spin around the Earth. They came out, first they launched in October of '97, and they spun around and passed by Venus the first time in 1998, and they got a boost. As you're coming close to Venus, the gravity of Venus is speeding you up. And then you scoot by it. Since you're going faster, your orbit goes out further. And so it went out further the next time it went around, and it passed by Venus a second time. That was in 1999. And they got another boost. And so it got faster, and it's swinging out, way out. It passed by Earth. I don't recall, it was pretty close to Earth, but like 300 miles away or so. And then it scooted out into space and came by Jupiter. Now the gravity of Jupiter is pulling it faster, okay? And so it even went faster and further out, and that's what brought it to Saturn. It took 7 years to do that.
So were they sure that this was all going to work?
Yeah, this is all done by computer.
Oh,
Use a
okay.
computer simulation.
Right,
you know where all these things are supposed to be.
All right.
And you say, hey, look at what's going on. We can use all this gravity to get out there, even though we have a rocket that can't do it. Okay? You start out with a rocket that can't do it, and you boost up the speed, and you can get there.
Was it the first time that this actually had happened, or they've done it?
They've done this before.
Okay, so they had the data.
Yeah, like the Voyagers. Okay. They went
all
by
right.
and they speeded up, and then they went shooting way out in space.
All right. I just find it fascinating.
It is fascinating. It's pretty wild. Okay. What else can I tell you about that one? They did the flybys of Venus, did all of that. Well, while they were going by Venus, they were checking for lightning in Venus. You know,
Wow.
There's all clouds around Venus, so there's probably lightning. So check that out. They did some other tests while they were doing it. They used their radar instruments to check the planet's surface. What else can I tell you? Oh, yeah, here it is when they came around Venus. It was about 370 miles away that second time. The first time it was about 176 miles away. So it was a little further away, but still well within the gravity thing. When they came by Earth, it was about 728 miles out. So I said 300 before, it was 700 miles out. Then they got to Jupiter and passed by Jupiter and got that speed up. There's a next image, we'll show you Jupiter. They took a picture of Jupiter as they went by. And so they got a boost there. And then on the way out to Saturn, they took a picture. Take the next image, if you will. And this is a real tough one if you're straining your eyeballs and look up to the upper left area. There's a tiny dot up there. That's the Earth. Okay.
Wow.
I take it back. This is not the Earth. This one is, they were taking a picture of Enceladus. That's who it is. Enceladus was up there. That's one of the moons, and you can see how far out that is compared to the rings. You can see the rings around Saturn, and then far out is this one of the moons of Saturn. The next picture, if you bring up the next image, is you can see a couple of dots on there, dark dots. Those are storms, and they saw some pictures of storms on there. Then the next image, if you will, this is a little tiny moon of Saturn, way out. It's called Phoebe. Look how pockmarked that thing is. That was hit with a lot of rocks, I'm sure. And if we bring up the next image, is Titan. That's the biggest moon of Saturn. And you can see there's a haze around. See that purple haze? That's the atmosphere. So here's a moon with an atmosphere. And that was taken in 2004. So here we are. We're up at Saturn already. We're taking pictures close by. The next image, okay, that one is early photos of Lapidus, another moon, and it has a long mountain range. And they got a close-up of that. If you take the next image, you see a close-up of that mountain range. So they got a lot of nice pictures that way. And let's see if I can see any others. The Huygens lander was still attached in July of 2004 when they got up to Saturn. And then Cassini fired its main images for 96 minutes to enter an elliptical orbit around Saturn. So now our spaceship is going to go around Saturn. It's orbiting around it, and they had to use their engine to insert itself into that orbit. If they didn't use that engine, guess what would happen? Keep on going out into space.
Oh, okay. I was thinking maybe it would burn
You don't
out.
stop in space. You
Okay.
know, you got to put the brakes on. So they put the brakes on with this engine firing. And so they started a 13-year in-depth exploration of the planet, its rings, and its satellites, with scores of remarkable discoveries. This is the report that I got this right off of the NASA site. If you go to the NASA site, you can see this whole report. And in the first few months, Cassini completed 3 flybys of Titan and discovered 2 additional moons orbiting Saturn. So they're discovering new moons. They hadn't seen these before. They took the first close-up photographs of Saturn's outer moon, Lapidus, on December 30th of 2004, showing this long mountain range. And then we get to landing onto Titan. And the next image, if you will show you it parachuted down. Well, we said it had an atmosphere. Well, if it's got an atmosphere, you can use a parachute. Okay? So that's what the Europeans did. They built this lander to come down with a parachute, and you land with a little bit of a thud, you know. And then once you get down there, you can take a picture of the ground. This is an artist's view, so that's not exactly what the thing is there, but it makes it nice and pretty. If you go to the next picture, you actually get a view of the surface, so you can see what the surface of Titan looks like. And that descent took about 2.5 hours. And once they got down there, they could analyze the atmosphere as we were going down, and then start sending pictures back once you get down there. It was a 700-pound probe. Now, Cassini itself was, if I remember, about 6 tons. You take Cassini with its probe on it, the 700-pound probe, about 6 tons. That's why it was not feasible to take the rockets that we had and send this up to Saturn. The thing is too heavy. And so you had to get those extra boosts, those accelerations from gravity to make the trip the way they did it. And let's see, what else can I tell you about it? They got lots of data, 376 images during the descent alone. So, I mean, they just took lots and lots of pictures.
And all this is on the NASA's site, right? Anyone can go into their website and see.
You can see this report, whether you can see all those images. I mean, 300, you might have posted all of them, I don't know. I didn't try and go through all that. Okay.
But NASA's a great site. For those of you who've never been on there, you can see videos, you can see images, reports, and all that is free to the public. You don't have to be a member or sign up, or and I'm pretty sure everything is copyright free, so you can reuse them for other.
I think some of that stuff they do copyright.
Okay.
So you got to be careful, because they'll bring stuff in that is copyrightable.
Right, but I'm saying.
And so those things.
Right.
The
but
copyright states.
a lot of it is free for people to use, and so it's a great site. NASA, I think .gov, right?
Yeah. So if you bring up the next image, we'll see Enceladus, and I always have trouble with that name, so I'm going to have to keep reading it off the page, because I can't. My memory just won't allow me to get it. There's a picture of Enceladus, and if we look at it, we'll find that it's got stuff coming out of it. Let's take the next image and take a look. Look at that. It's spraying stuff into space. In fact, some of that stuff forms the E-ring around Saturn. And so that's why those rings have distinguished patterns. They'll have spaces in between, because each ring comes from a different source. I don't know what all the other sources are, but at least they found that this material was coming into the E-ring. And so one of the rings is supplied by the debris coming out of Enceladus. Well, what is this stuff coming out? It's water vapor. And how come we're getting water vapor out of Enceladus? Well, it turns out that it's got an orbit that's not completely circular, because it's not completely circular. In fact, it doesn't even have an orbit. I should not use the term orbit, okay? It's stationary in space. It's one of these things where everything, you got all these moons out there, things have to be in a steady state, or else it'll all disappear. If it's in steady state, it'll stay there for years and years and years. And so, because of the gravitational pulls of all the different moons, this particular one just stays in place. So Enceladus just stays there, but it moves in and out because there's another moon, Diane, that is coming by every once in a while. And as this thing moves in and out, the gravity changes, right, from Saturn. Saturn's gravity is pulling on this, but as you get further away, you got less gravity. You come in closer, you got more gravity. You're squeezing the planet with gravity, and that heats up the inside. And that warmth can melt any ice. And so if you take a cross-section, you'll find water in there. And that water can spread out through these holes in the ice that's above it. So you got an ice cap, water underneath, and some of it escaping through little holes and spurting out into space. Pretty wild stuff that we hadn't seen before. The next image is on Titan. Let's bring up another. There's a lake on Titan. Well, it's not water. Sorry about that. It's so cold you can't have water in a liquid form, but you can have methane in a liquid form. And so we got a hydrocarbon sea on Titan, and there's a picture of it. If we go to the next image, we see that purple haze again. That's the atmosphere of Titan. And so Huygens probe successfully landed and is bringing back all, well, it couldn't see the lake unless it was up in the air, but you can now see the stuff from down below. And so they got plenty of images from the Huygens and data. Lots of data came back from the Huygens as well. Very successful. We got a whole bunch of images. If you bring up the next one. Okay, that one is Rhea, is one of the moons. Bring up the next one. That one is the one I told you about before, Diane. That's the guy who's making Enceladus move it back and forth and heating up the center. The next image, that one is Tethys, or Tethys, I guess is the proper pronunciation. And the next one, oh, look at the big hole on that side, big space, Mimas. And if we go to the next image, we're going to see a little bitty guy, Delphinius. He's in between two rings. There's a ring on the top, a ring on the bottom, and a space in between.
So he's not away from the rings. He's actually...
This picture just shows him in that gap. Okay, he's in the gap, but his gravity is causing the wave. See the wave on the bottom one? Mm-hmm. Yeah, that is caused by the gravity of Delphinius. Bring up the next image. That one shows a hexagonal cloud. Look at that. That's at the Saturn's North Pole. At the North Pole, it's got a hexagonal pattern to the... That's an unusual thing. I haven't seen anything like that before. Take the next image. There's a white storm on Saturn's northern hemisphere. That white stuff is a storm. And so they picked up that image too. Here's a nice image, the next one. Look at that. You can see all the rings of Saturn. And they told the people on Earth, we're going to take this picture, and Earth is going to be in the picture. So they told all the people on Earth, look up and smile, okay? Because your picture's being taken. See that dot in the lower right? That's Earth.
That's us waving. All right.
That was the one that I mistook before. I said, oh no, it was Titan. But here is Earth in the background, and you can see all the rings that they took. So that's a pretty impressive shot. Okay, I'll leave that one down. Now we can get into the next picture, image. We got, this is Enceladus, a cross-section that they've drawn up to show you that hot interior. Okay, and this is because you're squeezing it and unsqueezing it, things are going back and forth, you get friction. It gives you the heat. That heat is warming up, that blue area is the ocean. So that's an actual water ocean. Okay, even though this is so cold up there, the temperature on the surface is about minus 324 degrees Fahrenheit at noontime. I mean, the hottest you get is way cold. And that's because the surface is so shiny. It's reflecting all the energy from the sun. And so this is the coldest planet going. Coldest moon, sorry. And so the surface, that's all ice up there, the ice cap over the blue region, which was the water. And so now the certain parts of it is getting so warm, you can see up towards the top, there's a yellow spire going up. That's some of the hot water going up, and it'll melt a hole into the ice cap. And once you get a hole in it, then it spurts out the geyser. And so that's what's going on. And I got a cross-section. The next cross-section is a picture of it all blown up, so you can see that water. You can see the crust. You can see the things coming out the top, the geysers. And then down at the bottom, from the heat, is boiling up geysers inside the ocean of water. And I think that's probably the last really important one. Unless you go to the next image, it's a summary where they got all these numbers about all the different things it did. It went 5 billion miles it traveled over the 7 years that it was, well, first it went 7 years to get there, and then it spent another 13 years examining everything. So you had 20 years of stuff, and all that traveling, 5 billion miles. That's a lot.
And I think the last point that I'm pretty sure you're going to make, Richard, is the fact that people would remember this project because they had to do something at the end of its life. And putting
the end of life. If you left that satellite out there, it's run out of fuel. Okay, it got to the end, the fuel is disappearing. It's just going to be a dead object. It might crash into one of the moons, and any microbes that are aboard would contaminate that surface of the moon, and they didn't want to do that. So what they did is they changed the orbit to go up and down through the rings and take all the data on the rings, and then finally dive into the planet and destroy itself, but take data on the way, take data on the atmosphere itself and how much pressure was there, what constitutes it. And so it dove into there in September of 2017. That was the end life dive.
Amazing. And when you were talking about all this, I kept thinking, gee, if I was involved in this project from the beginning at NASA, I'm wondering if I would still be there in the end.
38 years, I mean, that's a career.
That is a career. And
if you start out your career on it, you might still be there.
Right, but most of those, I'm thinking.
You start out and your career is half over, you're out.
Yeah, especially if you left before it actually got to its destination. Mm-hmm. Well, it's fascinating information, and I appreciate you coming and spending time with us. And we're going to have one more space program this year. Right now it's scheduled for December, so we'll figure out what we're going to be talking about. So Monday, December 16th for all you space enthusiasts.